Hey, how's it going? We're the last day of Infocom. I'm sure your feet are killing you, want to get back home. So we're going to make this quick and fun. I have 20 minutes in front of me. This is going to be a very high-level conversation about virtual switching. Let's see if the slides work. There you go. All right, so quick show of hands. I would just want to understand what you do. If you work in IT, or you're a field tech, or you've touched a network switch for whatever reason, please raise your hands. Excellent. I can see why you're concerned about this. So virtual switching, as the name suggests, we're talking about the latest frontier in networking, right? If you've gone through your trainings with switching and CCNAs and all the good stuff that's out there, we're seeing a lot of people talking about virtual switching. This conversation today is going to be very high level. We're only going to be touching on the concepts of how virtual switching works, but the hope is that this can promote, that you can promote this within yourself, your organizations, and understand that a lot of changes are on the horizon with virtual switching. Now, before we get down into virtual switching, it would be amiss if I didn't touch on the history of networking, right? We're not going to go down to the basics. I'm not teaching you the OSI model today, none of that. What we're going to talk about is how networking became a thing. And particularly, we're going to talk about packet-switched networks. Now, packet-switched networks are foundational in today's networking. And the history behind it is a gentleman named Paul Barron. His research led to what is ARPANET, which at the time was the world's biggest packet-switched network. Now, there are some principles that he talked about that still hold relevant in our conversation today. So as he was doing his research, he had a task in front of him. They asked him, we want you to figure out packet switching. How are you going to do it? And so this is what he coined as the principles of packet switching. The first principle is survivable communication. Prior to that, what would happen is the restriction on data transfer was whatever medium you were using for it. Fiber optics, cables, copper cables, aluminum, it didn't matter. You were kind of stranded by whatever infrastructure that you were using. Packet switching helped change that by letting you traverse multiple hops by going from point to point. The goal was also to have a large-scale network, right? They wanted it to be distributed and basically no central control. Now here's where we have a little bit of a deviation from what we're used to hearing. When packet-switched networks first were conceived, the idea was that it would be impossible to have a central control location, right? What happened is, even though that was how it was managed, we didn't have that luxury because of hardware limitations. We still had centralized hardware. We had entire server farms. We had purpose-built devices that were being utilized in conjunction with your networks to create whatever infrastructure you needed. The challenge with the traditional infrastructure was that the installation process was long and very involved. Now, I know on this very same panel on the stage, a couple of days ago, we were talking about trends in AV and IT, and we were brushing on how a lot of people are still adopting IT. Now, this session today goes way beyond that. But the fact of the matter is, irrespective of your journey as an audiovisual technology professional, wherever you stand in terms of your network involvement, virtual networking and the advances that's happening on the networking side of things is going to keep on happening. You can't necessarily stop that, right? So going back to the traditional infrastructure, the challenge was that it depended on the size and scale of the organization. So if you had a single building, sure, we could do that. Installation is still challenging, but within a building it's fine. But then you had large campuses, you had higher ed facilities, you had entire villages, you had systems where you'd have to span the entire city, miles, thousands of miles. Scale was the challenge with traditional networking. Now, what has happened is that the landscape of networking is changing. What we're seeing today are global networks, right? Have you ever, show of hands, have you ever tried to ping google.com? if you have, you're going through multiple servers. Depending on your location, wherever you are, you're going through several hops that could be several countries, cities long, but it is still instantaneous. The networks that are built today are global. The challenge, though, is that the throughput requirements, and we have a huge role in that, have changed. Now, I hope, I'm not going to go into details, but go on, and if you don't know, there's a difference between throughput and bandwidth. Please note that I'm saying throughput. The throughput requirements vary depending on the type of traffic, including media, voice, IoT, and others. Now, we know that no matter what you develop, no matter how much, now I work for Audinate. We are at the forefront of audiovisual technology over IP. We've developed some of the most commonly used products out there. But the fact of the matter is, the technology that transports these things are still the networks. And the networks are not built by audiovisual professionals. They are built by the networking companies of the world. So whatever they have in place, we have to use that. And we, as some of the major users of that common pipe, we kind of dictate saying, you know what, I would really like that 1 gig. You know, I want that 1 gig. And the network guy will tell you, yeah, it's fine. You shouldn't have a problem. Our switch has the biggest backplane in existence. But then you look at it, you've just taken down an entire network by plugging in a small AV over IP transmitter, right? So we are still beholden to whatever technological limitations there are, but we want more. We want more throughput. The requirements keep on changing and evolving and grow every day. So, the solution. Let's go virtual. Now, how many of you have heard of virtual LANs, VLANs, show of hands? How many of you have heard of virtual computers, show of hands? How many of you have spun up a virtual server on whatever platform? There you go. I see a lot of hands, and that's a good sign. It's a legitimate way of operating several things on the network. Now, the beauty of virtualization is that it separates your software from the underlying hardware. So the hardware is there, your server stacks are still there, you have massive servers that's capable of doing a whole lot of things, but what you've done is that you've taken the software platform and kind of liberated it from the hardware. Okay? Now, hardware can run operating systems or other custom applications, and the best part about going virtual is that now we go into the conversation of CapEx, capital expenses, versus OpEx, which is operating expenses. Hardware does not have to change all the time. You can run the life of whatever server life you have, but the softwares can keep on evolving and you can adapt it to whatever changing network technologies that you want to do. So there is a justification for going virtual. And whatever application you're using virtual platforms on today, it's only going to keep on growing because the IT departments find the ease of use with having a virtualized platform is amazing. They don't necessarily have to go to their senior directors and say, my server's going to die, I need to upgrade that, because when you buy a server, it'll last you a couple of years. It makes more sense to say, my software needs an update, we may need to buy a couple of licenses. So that's the whole CapEx versus OpEx. And the reason why I put together this slide is just to show that going virtual does make sense. And the reason, the whole narrative behind this conversation today, is we're trying to build a picture towards virtual switching. Now, what exactly is virtual switching? Now, the coolest part about virtualization is that virtualization is the foundation of cloud platforms. Now, you will notice today that I'm just going through a bunch of slides, talking about a whole lot of terms. I will not go into manufacturer specifics because the information is meant to be generic. You have the liberty to go back and research it and develop your skills depending on what your requirements are. So, virtualization is at the foundation of cloud platforms. Organizations of any size can leverage the cloud. Now, if you've ever had to create a network where your office location is 1,000 miles away from your other office location, but you're a really small company that only has like 5 employees in each office, the challenge of having a leased line to have a dedicated circuit between those locations, the costs associated with it are massive. What does the cloud do? We use the infrastructure that all the cloud providers, the Microsofts, the Googles, the Amazons of the world have already built. We leverage their platform and build out our system. So we have servers that can be remotely located. It's all located in the cloud, right? I actually Googled a funny cloud joke that I could say at this point, but it's all up there, so I don't know what I'm going to say. So the point of the matter is, cloud is at the foundation of today's advances in how you use and deploy your IT systems. And the beauty of the cloud lies in virtualization. That's why cloud vendors, the providers of the services, are able to do it, because they have dedicated hardware resources that's right now running the platforms that you need. And when you decide to say, expand, you say, I'm going to grow this, they can add a couple of processors for you. They can give you a couple of virtual space. If you don't want it anymore, they can scale back, right? So, moving on. We're going to talk about network function virtualization, NFV, okay? Now, before I get deeper into this, a quick show of hands, have you heard of SDN? All right, I see a couple of hands out there, software-defined networking, right? Now, I have more details on that, but network function virtualization is extending the power of networking to a virtualized environment. So now you're used to networking, you have your network switches, you're used to plugging things into it, and what do? If you have, say, a classroom that has 10 audiovisual TXs and 10 RXs, you're going to take them on, you do your traditional, the most commonly used phrase in AV, build an AV VLAN or put a subnet on it, and you put those, and they're supposed to be talking to each other, right? What we're talking about here is taking virtualization to that networking. The principles, the concept of networking, where the idea is to take point A to point B, does not change. But how you accomplish that changes with virtualization, which is why network function virtualization is a huge concept that is at the foundation of all of this new advances that you're seeing in networking. Now, according to researchers, market researchers say that by 2024, just the network function virtualization component of the market is going to be $40 billion. It's a massive market out there. And the fact is, we in the audiovisual industry who leverage the network every day, whether it be for your control traffic, your audio traffic, or your video traffic, we leverage it every day. It's important that we kind of understand and keep abreast of what's happening, right? What it does is that it gives you the ability to take your media globally. How many times have you had a conversation, if you're a part of a large corporate organization, and you'll say, is there a way I can take my audio and send it across to London? Can I send it to Australia? And the response is, the latency is going to be a challenge. I will need a dedicated pipe or a dedicated link that's going to cost me tens of thousands of dollars. It's not going to work out. What NFVs do is that they give you the ability to leverage the existing infrastructure that's already in place to a virtualized platform and expand on your networks. Let's talk about some NFV terms. Now, these are just terms. Again, I'm just trying to get you into that mind space where you're trying to learn more about NFVs. So network function virtualization, the first set of terms that I want to talk to you about are components. Now, in components, there are solutions, orchestration, and automation of networks. So if you ever worked with or are going to work with a provider of an NFV related service, you're going to say that we are a solution provider, or we do network orchestration, or we automate your network. There are very specific applications within the NFV domain that a lot of companies specialize in. So this is outside of the realm of the cloud providers and the networking providers that you see every day, right? Now, the other type of providers that you're going to see in the NFV landscape are providers of applications. They build you virtual appliances, right? So these are the appliances that you are going to use in order to build out your networks. You don't have to patch a cable to your switch and put in a bunch of code that creates like access control lists and all that good stuff. virtualized appliances that live on top of a hardware platform that's existing is going to be the future of NFV-based appliances and applications. Now, here is the fun part, right? I always like to talk about this. Whenever AV and IT and we talk about the cross-section of the different technologies happen, there's a very common thing that most audiovisual professionals say: there's no standards in AV. We don't have any standards. We keep changing. Whatever standard is the standard of the day kind of thing. I don't necessarily agree with that. There are plenty of standards that are commonly used today. And if you think that audiovisual folks are the only people dealing with that, that's absolutely wrong. IT and the underlying technologies that build up IT also have similar challenges with standards. If you look at NFV platforms, some of the standards in existence right now, so there's something called Etsy, not the place where you buy the cool stuff. There's also an open platform for NFV. There are open network automation platforms, open source mono, and MEF. These are just a bunch of different standards that people are trying to implement. There are no standards in network function virtualization today, right? Once it's established, everybody's fighting for that space. Again, remember, in a couple of years from now, this is going to be a $40 billion industry. And as we go down through the slides, you'll see how some of these things are probably already relevant to you. This is kind of like the high-level concept of what this is, right? Now, some of the advantages of this are it's rapid deployment and you can be remote. How many times have you wanted to set up a network switch and said, I can't do that, I don't have a tech on site? In a world where networking is governed by virtualized networking, you will not have to fly in to do this because the underlying technology behind this is already established. You have control over the virtual layer of it, right? It scales up and down easily, there's flexible licensing options, and you can overcome legacy network infrastructure problems. There are also challenges, right? Security and privacy is a huge, because again, standards kind of determine what security is. So if you don't have standards, you are unable to set those standards and security practices. There's a lack of business cases too, and the general lack of standards kind of curtail this. Now, before I end the conversation, I do see there's a couple questions that have came up. I want to address them as well. Just so you have an understanding where NFV and SDNs are different, network function virtualization separates the networking services from the dedicated hardware, okay? So understand this, you have hardware, mostly servers, that are acting as your switches, not the traditional switches. These are servers that are doing the network transportation for you. Again, very easy to do. There are NICs available that are several hundred gigs of bandwidth capable. That's kind of how they establish that. That's what the network function virtualization does. Now, how does that differ from SDN or software-defined networking? Software-defined networking separates the network control function from the networking port of it, right? Now, it can be virtual, it can be physical, right? If you've worked on Cisco networks, they have SDN. Several of the major switch manufacturers today have software-defined networking. And the way they do it is that they have their hardware platforms that's doing what you traditionally do, but they've built on top of it a control plane that is your software layer. So you don't necessarily have to go about patching now. You still have to do patching depending on how the hardware is, but you have a virtual software-based control layer, which you can do from anywhere, right? Now, SDN allows network control functions to be automated, which makes it possible for the network to respond to whatever changes that's happening. That's what SDN is. So basically, SDN is a functionality of network function virtualization. A switch can have SDN. It could be virtual or physical, right? So that's kind of like the difference between this. I know these are very high-level concepts, but it's important that you start thinking about these. There are a few questions that I quickly want to address. One of the questions that came up is, how do I learn more about this? I figured you'd ask that. Are there any certifications? Well, the best way to learn about virtual platforms is to go to the famous websites out there like VMware or Google or Microsoft. They all have their own free downloads of the software. Download it on, run a virtual machine, and see how virtual switching works. Create a tiny network and do that. The other question that I want was, how does this affect me in AV? Now, real quickly, as long as audiovisual technologies rely on the network for transporting your media, control, audio, video, you're going to have this. It's going to be a part of your life. So take the time, invest time in learning more about virtual switching. It'll help you down the line, and it also gives you the opportunity to build on your AV skill base. Thank you very much for your time.